In this video, we'll continue our discussion of the chain rule by working another example where we have two independent variables. So we have the function w. I wrote the formula on the screen there. This is the same through that for each one, so we'll find each one. I have w there, and then I have a definition for x, y, and z, and notice each x, y, and z are defined with u's and v's. Meaning, in this case, we have two independents and three intermediate, and then one output. So let's go ahead and begin by finding our partials. So it's the partial of w. Let's go through each one. Respect to x, right? So the x, there's only one, so the z in that definition is going to count as a constant. So remember, the derivative of arctan is 1 over 1 plus the argument squared. So it's going to be over 1 plus, and then it's going to be x squared, z squared. And then we have to times it by the derivative of the inside with respect to x, which is just going to be a z. All right, so we got z squared over 1 plus x squared, z squared. I also need w with respect to y. Well, there are no y's, so we get a 0. That's nice. And then w with respect to z. Now notice there is a z here, and there's a z there, so we actually got to do a product rule between these two terms. So it's going to be the partial of z times arctan of xz plus, I leave the z there. Now I take the derivative with respect to t of that arctan, of z, of the arctan. All right. That is going to be equal to, okay, I get a 1 there, so it's arctan. Not the prettiest thing, but that's our answer. And then we're going to get, okay, I have a z on top. And then it's over 1 plus xz. Both of those are squared. And then xz times xz with respect to z is just going to be an x. So we get that arctan, or the derivative of w with respect to z, will be the arctan of xz plus xz over 1 plus x squared z squared. All right, so there's those. I'm going to shrink these down so I can write more in one screen. All right, so I have those. Now I need, we have two variables, we're doing u and v, so I'm going to need dx du, dy du, and dz du. Let's do those first. So I got 1/2 u to the negative 1/2. There is no u and y, so that's 0. All right, and then z, z with respect to u, that's a cosine, so it's a negative v sine u. We also need dx dv, dy dv, and dz dv. Now, these should have all been curvy here, all partials. So go ahead and fix that. Those are all partials because they're defined, I guess really not really, x and y are defined only with one u and one v, but we'll use that since the whole problem has both independent variables. X with respect to v is 0. Y with respect to v is negative e to the negative v. And then z with respect to v is just a cosine u. So dw du is just going to be z squared over 1 plus x squared z squared times 1/2 u to the negative 1/2. The zeros and the y's are gone. So I got plus arctan negative 1 xz plus xz 1 plus x squared z squared. And that's going to be times negative v sine of u. And then we would replace x, y, and z. I'm going to keep it there because we got to do this whole thing again right there, and it's going to take up a whole lot of room putting this everywhere there's a z, everywhere there's a y, and everywhere there's an x. It's actually not terrible now that I'm looking at it. I've debated doing it. I think we're okay. We'll do it on the second one. Okay, so dw dv now. right? It's the same thing here. I'm just going to go up and snag these. I know you guys can't. But I have that times 0. Oops, I should have looked ahead of that. Then I have this thing times the second, which is negative e to the negative v. And then our last thing is, oh, that was our z. Okay, hold on one sec. That is our z, so I'm going to move this down right here. What goes right there is our y, which is a 0. So actually, that just clears that out again, even though it's exists over here, but the 0 for the dw dy. This makes sense. Y doesn't actually affect w in any way. All right, so I got that now times. So let me shrink this down. Actually, can I just scroll? Nope. All right, let me shrink these down to give myself a little more room. This is going to be times cosine of u. So for this one, dw dv, that's 0. That's 0, and I'm just left with these. So I'm just going to go ahead and replace. Okay, this is going to be a little weird. Tangent arctan of x, which was u to the 1/2, times z, which was v cosine u. Really gross. Plus, okay, xz. So it's u to the 1/2 times z, which was v cosine u, all over 1 plus u times v squared cosine squared u. Gross. All that times cosine u. It's not pretty, but everything now is in terms of u and v. We could have done that for this one as well, but as you can tell, it doesn't make anything pretty. It just puts everything in the correct variable. Now, if I were to plug numbers in, like in the last examples, I would have just plugged in u's and v's and got x, y, and z, and then plugged them in where they were appropriate. You can tell, like, notice that this turned into this big mess turned into all that. You can see that turning this one into just using v's, it's going to be really gross.